Hey everyone, in this video we're going to look at applications of logarithms. The pH of a given substance is defined by the equation pH equals negative log of the hydronium ion concentration, which is measured in moles per liter. For part A, we want to determine the pH of milk to the nearest tenth that has a hydronium ion concentration of 3.16 times 10 to the negative 7 moles per liter. So this is an easy one because pH is already isolated in the equation that we are provided. So we're going to simply substitute in the hydronium ion concentration of 3.16 times 10 to the negative 7 moles per liter, where it belongs in that equation. And then we are going to go to our calculator in order to calculate the pH. Keeping in mind we want our answer to the nearest tenth. So that's going to give us negative log of 3.16. Second comma to pull up the times 10 to represent not scientific notation. Times 10 to the negative 7. Close that off. And we're getting approximately 6.5 as the pH. Alternately, you could have just done negative log 3.16 times 10 to the negative 7 as the argument. And that's equivalent. Moving on to part B. A papaya has a pH of 5.2. This time we want to determine the hydronium ion concentration. And we want to provide our answer in the form specified. My suggestion would be to write down the equation that you were given. And then we're going to think about how can we isolate hydronium ion concentration in the general case. The strategy I want you to use is to first isolate the logarithm with its argument. In this case, we have the negative. It's essentially negative 1 times log of hydronium ion concentration. So we're going to divide by negative 1 on both the right side and the left side. That is going to give us negative pH equals log of the hydronium ion concentration. Remember that this would be a common logarithm because we don't see a base. We assume that is a base 10 logarithm. So I would actually write that down to make it more obvious. And now we are going to switch forms. By switching forms, remember the base of the logarithm becomes the base of the power. The exponent comes from what was isolated in log form, and the argument will now be isolated in exponential form. Now that we have the formula for the hydronium ion concentration, we can simply go ahead and plug in the pH that we know, which was 5.2. So it's 10 to the negative because that's part of the formula. And then we're plugging in the pH of 5.2. Let's go to the calculator and type that in. 10 to the power of negative 5.2 gives us approximately, make sure you don't just look at the first few digits. At the end, you see the e to the negative 6. That means times 10 to the negative 6. So in the form specified, we're going to write down 6.31 times 10 to the negative 6 moles per liter. And now we are on to part C. In terms of its hydronium ion concentration, how many times more acidic to the nearest tenth is orange juice with a pH of 3.3 compared to tea with a pH of 7.2? For this problem, what we actually want to determine is what is the ratio between the hydronium ion concentrations. So the ratio between the hydronium ion concentration for orange juice to the hydronium ion concentration for tea. As you see in this last problem, we've already gone ahead and isolated hydronium ion concentration in the general case. So we can actually use this formula in the numerator for orange juice, and then again in the denominator for tea. So this will give us 10 to the negative pH for orange juice divided by 10 to the negative pH for tea. Sorry for that messy writing there. So that gives us 10 to the negative. For orange juice, the pH was 3.3 divided by 10 to the negative. For tea, the pH was 7.2. Now we can go ahead and type this into our calculator. 10 to the power of negative 3.3 divided by 10 to the power of negative 7.2. And that gives us, rounding to the nearest tenth, because that's what we were instructed to do, that gives us approximately 7,943.3 times more concentrated for orange juice. Sorry if you can hear my dog in the background. He's whining because he wants to come in the room. All right, everyone. Thanks for sticking around. Have a great day. See you again.